Okay, guys, so today we are at a major topic at the front, at the entrance to a new and very important topic with which we are going to occupy ourselves for much of the semester. So the idea of the derivative. So the first problem is called the tangent line problem, and it consists in the following. Given a curve, C, how do we find the tangent line to the curve at some point AB on the curve? And my first question, let's see, what would you say? That's always something you want to ask yourself. Why is this a major problem? Why would anybody care? So let's see if you have any sort of musings. They don't have to be right or wrong musings, just what do you imagine? You can just say it's not a problem or you don't find it interesting. That I would also be happy to hear. And of course, guys, as always, it would be nice if I can see your faces. You see, my morning face cannot be as bad as yours. So Kirill says tangent line helps us determine the slope of a point. But you see, guys, you are not answering my question. I mean, maybe that's one reason why a lot of people just are not interested in mathematics or in calculus. They see nothing that it relates to, nothing that matters to them in what you call their real life. So I'm asking you very simply several things, right? You all are registered in calculus. Have you ever wondered what you registered in? What is the subject that we are studying? So calculus, so what is that we are doing here? Isn't it an interesting question, guys? You're sitting here waking up in the morning. What is it that you're doing, right? I hope you ask it of yourselves. I do. So nobody wants to say anything. Okay. Let's see what I have to say about it then. So the simplest possible curve is a line. So a complicated curve could be then analyzed in terms of line segments. And why would that be of any interest? Let's say, for example, this. So one thing that I actually always wanted to do, I wish I had the budget, is to build your roller coaster, right? So, you know, I have so many interesting ideas, right? Let's say a student doesn't answer a question correctly, I press a button, and then it's like in this slingshot on Coney Island, if you know what it is, right? You start flying up and down, it shakes you. Of course, I'm worried maybe some people enjoy that way too much, and then that will not be so helpful. So what you have here is, this is a roller coaster that I built. And you might ask yourself, are you safe to ride it? So imagine that you have this, it's a gravity powered roller coaster. So you have this pathway, yes? And I attach you, so in other words, you cannot, your cart is entirely attached to this path. It will not depart from it. will it go through this curve? Will it go through the loop? That's what you want to ask yourself. And of course, any arbitrary curve is very complicated, but understanding motion on a line is already much easier, okay? And then you can realize that that what you can do is you can think of what happens to a mass when it's moving. That's just arbitrarily moving down in this case, but it could be also moving up, doesn't matter. If it has an initial velocity, what would be the situation? And you can have all sorts of considerations. And for example, ask yourself, what is going to be the, what do you think, guys, is the question, right? So what do you think is going to be the final cart speed if the cart travels through the black path, or if it travels through the red path? Which is going to travel faster at this moment, at this point, not moment to be precise, right? So once you reach this place where I'm holding the cursor, which cart is traveling faster? So so Steven says black, Anis says first one, another person says red. Interesting. The fact of the matter, they travel the same speed. Once they reach that point, they travel the same speed because that's the same difference in altitude. And I can prove that by analyzing what happens when we move along a line. You understand what I'm saying? Again, guys, okay, Kirill, nice to see you. Good that a few people are showing me something about their expression. It would be really nice if we could build this thing. You will see how it works, okay? So again, to those of you that are just joining, let's see, have they joined? Hello, good morning, Alexa. Nice to hear from you. It would be nice to see you too. Great. So again, we just mentioned the tangent problem. And that's not the problem people are occupied with when they wake in the morning, right? So we asked, what is calculus? That's one major question that we try to answer. When you are sitting here, always wonder what is it that you are doing. And the second is, why do we care about finding tangents to the curves? I'll tell you other reasons later on. Okay, so one reason, as I mentioned, is if you study a curve, the simplest possible curve is a line. And here you see, you can see that you can realize that any curve is can possibly be built out of many line segments. Okay, and then analyzing the motion on a line will in fact reveal what would happen on another curve. Okay, so we spoke about those roller coasters. So that's the situation. I can imagine building, it's like Lego blocks. That's what you do, right? You build a curve out of tiny line segments. I just made them exaggeratedly large. And that's the general philosophy of what you do in calculus. It permeated quite a lot of aspects of our existence. So for example, you are watching the screen. The screen is made out of pixels. All the complicated colors you are seeing are combinations of a few simple ones. Okay, so out of simple colors build a huge array of much more complicated spectra. And then when you consider, well, that's the pixel. When you consider volume, you can imagine building an object out of the Lego blocks. In other words, imagine building Batman out of many, many tiny Lego blocks. The resolution will be pretty great, right? You can build any sort of shape. So the idea of calculus is, and that you do the same thing when you consider waves. When you're hearing my sound, it's a juxtaposition or construction of many sine waves of different periods. Okay, so you can actually, the idea is that you will build something very complicated out of many instances of something very, very simple. And that's what calculus is, just build something out of the pixel. Just you have to figure out what's the pixel, what's the simplest object that has this property that you are studying. And then you think of using that simple object to construct everything you see around you. You want to see what's the limitations of that or what things can you explain. Okay, So then second condition is this. Okay, so why tangent line? So if you look at Newton's law, so imagine that we have a spacecraft and it's traveling along some loop, some pathway. Okay, now if it does not travel in a straight line, that means that there is a net force acting on it that's not zero. So the object, according to Newton's law, will travel at a constant speed in a straight line if no net force, no positive or negative net force is acting on it. Okay, so for example, if I have this rocket and I release a satellite, I just release a satellite, the satellite will fly at a trajectory that is aligned tangent to the curve. Okay, that's what would happen. So so when you speak of tangents to the curves, you are talking about the implementation of Newton's ideas. So another thing, as I mentioned already in the very first lecture, is suppose we want to consider instantaneous velocity. Instantaneous velocity, just like we did when we introduced limits, it's mathematically the same as calculating the slope of the tangent line to the curve. So finding tangents to the curve amounts to mathematically the same idea than when you are calculating what was the velocity in the video that we had in the first lecture. So you always, guys, and you can talk to me. I mean, unfortunately, not enough of you are doing that. You can tell me if you are, even if you are bored by something, you can tell me I'm bored, and this is not what I find exciting. I'm also interested in to know what is it that you love, what is it that you are interested in. So when you study something, always ask yourself, what is it for? What is the statement really about? Because that tells you if you understand it. If you cannot explain it in simple words, if you're saying we need to calculate the slope or we need to add something, then most likely if it's very technical, then you have no feelings for it. You have no sense of what it is about. And another thing, when you think of mathematics, you have to realize that many of the interesting ideas, there is no linearity. You understand that it's not like here this tangent line problem is for a particular purpose. Let me show you what I mean by how things progress. Right. So suppose that, let's see what you would say, guys. Suppose you needed to calculate pi. What would you do? Well, you don't have a calculator or you need to program some machine to do it. I don't know, but you don't have a device that will already tell you what's pi. What do you think you would have tried doing? I just wonder. You understand my question? Yes, guys. So just suppose that right now you needed for some reason to calculate pi. What would you have done? What's 22 over 7? Why would you say 22 over 7? Who? but why is it an approximation to pi? Why not? Maybe it is an approximation to pi. My question is, how do you come up with some idea? It can be, obviously in 5 minutes, I don't expect you to come up with a workable idea. I'm just asking you just to see what is in you, to see what sort of impressions you might have. What sort of pathway do you think to take? One obvious thing is, of course, you start thinking, what's the definition of this pi? And then how can you implement this definition? Just that I guess some of you are fainting. What I'm asking is interesting to you guys or not at all? That's Christian. That's a good idea. Draw a circle and try to make approximations. Essentially, right? Those are not bad ideas. We will talk about that more. I remembered something. Let me show you very quickly. I remembered something because an Austrian that I speak with sent me this video and asked me about this question. Okay, let me show you that question. Okay, so it's this.
Maximalstellen unendlich weitergehen, ohne ein sich wiederholendes Muster. Bis 2013 wurden 12,1 Billionen Nachkommastellen berechnet. Aber irgendwie ist Pi sehr viel mehr.
Pi taucht bei einer Unmenge anderer Phänomene auf, die zumindest auf den ersten Blick nichts mit Kreisen zu tun haben. Vor allem in der Wahrscheinlichkeitstheorie.
He's saying that pi appears in many instances that on first glance do not appear to involve pi at all. In particular in probability theory.
Taucht Pi relativ häufig auf.
So here's what you do.
Angenommen, ich nehme diese Nadel und die Länge der Nadel entspricht dem Abstand zwischen diesen Linien.
And the distance between of the two lines corresponds to the length of the needle.
Und nun angenommen, ich lasse die Nadel auf das Papier fallen.
And let me allow the needle to fall.
Lässt man die Nadel fallen, fällt sie manchmal quer auf eine Linie.
And
Und
when I drop
manchmal
the needle, it falls many times diagonally or across the line.
fällt sie zwischen die Linien.
And sometimes it
Es
falls
stellt sich
between them.
heraus, dass die Wahrscheinlichkeit, dass die Nadel quer auf einer Linie landet, exakt 2 geteilt durch Pi entspricht. Beziehungsweise circa
I
4.
can show you that now. Okay, so the probability that the needle will fall on the line corresponds to 2 divided by pi. Okay, and and then she wanted to know what sort of thing this is about. So this is this question, and I wrote her this argument. Okay. So you will not follow this argument because, well, you need, yeah, I just presented it here because I want to show you what sort of pathways do you take to come up with interesting arguments, with interesting ideas, and how indirectly are things related. That's why it's here, okay? So here is that needle. The distance between this point and that point is the length of the needle. So the needle is dropped. And when it drops, I note how I note the gap between its back end and a line, and I note the angle at which the needle was open. That's my my argument. Then the equations that I come up with correspond to a double integral. What is an integral? An integral is an antiderivative. So what is a derivative? A derivative is slope of a tangent line. Antiderivative is the reverse of that process. You understand? You will learn it at the end of this class what at least one part of it means. Okay, so you have slope of the tangent line needs to be understood in order to know what it means to take antiderivatives. Now to take and then you have trigonometry involved here. You see, you have trigonometry involved. You have all sorts of many ideas. They come together like small threads, and then this is what the result means. The result means that you can calculate, I can make it 1 over pi, it doesn't have to be 2 over pi, just change the problem slightly. I just solved the problem that was presented in this video. You can readjust, okay? So here is what you can do, guys. You understand? This is basically the conclusion of this mathematics. To calculate pi, just draw this paper and drop, you can just adjust it slightly. You can drop the needles. You can drop many needles. You just drop thousands of them, for example, right? And then count how many needles intersected one of the line. Okay. So what you will do is you will take total needles thrown and divide them by, so the reverse of that, right? Take the total needles thrown and divide that number by the needles that intersected, the count that intersected the horizontal lines, and you will get an approximation of pi. You see that this ratio will give you an, isn't it cool? You understand? The needles, nature will calculate what it is. If you want to see, I found another video where a person is kind of doing it. Do you want to see that video? Or you are tired? It's not in German, it's silent. German, by the way, another thing is, I love, oh my God, I even dream about certain weird things, right? So I do hope you're picking up a language, and if you are, we can discuss a better way to learn it. I always think about that as well. So let me know, do you want to see the needles dropped in another video, or you had enough of the needle and you want to move on? Type in the comments, please. In English, that you see, I don't like that you are so obsessed with English. You want to get out of your skin, you know. You want to hear other things. It's not in English. It's gonna be actually, quiet. You know, one of my torture instruments when I had another classes, just my God, it was so, they're so difficult. So they irritated me tremendously. I translated a video. It was a work of hate, and I made them read subtitles. I gave them a choice. You either watch a black and white video. It's for some reason it's terrible, right? It's actually very interesting. I'll send you that. It's about von Neumann. So here is, let's see. So it was the idea of Count Buffon. He came up with this many years ago in the 17 something. Here is the video, right? So this is the setup. You see, you have a bunch of needles. The needles, he actually selected 340 needles that he's going to drop. And he actually made the distance between the lines to be twice as much. And then this is what you do. And you see some needles intersect and some do not. You understand what you have to do? You have to count how many needles intersect the line. So you already found 51, 53, etc., blah, blah, blah. And now what you do is you take 315 and divide by that number. And the approximation the person got is 3.1, not too bad. You need more needles. Say you need to throw more needles and do the counting. Or you have other procedures that also are, you can throw darts into the circle. Throw darts, if the dart is landing randomly, that's what you have to do, then it will also calculate pi. That would be the more direct thing to do. Interesting? So the point is, first of all, is that ideas are not what they are on the surface, right? So the surface definition of that we have is just the immediate reason why we define this concept, but they are defined with great insight. You understand? You realize that something is, for whichever reason, very important. And the most amazing things are the things that you are overlooking, right? That's the terrible, taunting truth about our existence. I lived many years in Jerusalem, for example, and this is why it still is always in my dreams. is that it looks like it's very, very bright, very bright, the city, the way it looks. And it looks like somebody painted with a very thin on a very thin canvas, painted something very colorful and bright, but the canvas is deeply black, deeply. It's a void that is just, it's as if it's sitting right below the colors. And there is just such a slim distance from that void and this brightness that you are seeing. And that's what I think is just, this darkness seems to always be something that is smiling at you and taunting you. In other words, how can I explain it to you guys, right? That's the thing that you have, is that the most interesting things, the most important things that are in your entire existence are right underneath your nose. You just don't realize it. And that's why in mathematics, that's actually a very good example of it. Okay, so there is something there that's right in front of your nose that if you could figure out what that is, could make it conscious, it would be extremely, it would basically answer whatever is troubling you in your life. It's just you do not notice it because you dismiss it as unimportant. So what happened in this process, I just wanted to note a few ideas. So there is convergence that has to do with infinity in the concepts that built up the needle. There is the concept of infinity, there is trigonometry, there is anti-derivatives, which involve, you need to know derivatives and go further. And of course, many more ideas. So now let's talk about what is that tangent problem. I hope I convinced you a little bit that it's an important problem. That's why it's one of the central pillars of calculus. So first of all, you can see that you see in the circle, it's very easy to define a tangent line. And in a circle, it's a line that crosses the circle exactly at one point. You can see this is a secant line. Secant lines will cross the circle at 2 points. A tangent line crosses the circle at 1 point. But that's not a good definition for other curves, because here is naturally doesn't look like a tangent to us, correct? This line crosses y equals f of x, but it crosses only at 1 point, but we will not say that this is a tangent line. So we need to rethink our definition. So first, let's review what lines are. So let's recall the idea of slope. But before I do that, by the way, let me see what you think, guys. I mean, I'm always talking there. I'm not sure what you do there. Tell me, please, I want comments or conversation. What is a slope? What is it measuring? Why does it work? So the formula delta y over delta x, but my question is why slope? What is it supposed to capture? Why does it work? Rise over run, Christian, wonderful. But what idea are we trying to capture? Sure, but there are many changes. What exactly are we saying? Change, you say change of y over change of x, there are many, right? Clearly, there is change of y over change of x here, but what are we trying to say with the slope specifically? Why lines? But why is the slope so intimately tied with line? You understand what I'm asking, guys? Would you have thought of slopes if nobody taught you to do that? In a moment, I will say how I think of it. Okay, but you see, you need very clear thoughts. You have to really think about everything extremely clearly. So, do you know slopes? Most people, my impression is they do not understand what slope is. So they learned it. They might have calculated it, but they use the word "it," and "it" refers to nothing at all. All right, let's talk about it together, guys. Look at the typical line. Now I can take 2 points on the line. Let's take the 2 red points. You see me? 2 red points. I can draw a horizontal and a vertical line and create a right triangle. This is one right triangle I create. I can take any other 2 points and create another right triangle. What can you say is true about those right triangles? Well, sure. If it's a right triangle, there is and Leakey says proportional. Very good. Those right triangles are scales of one another. They look exactly alike. So, and that was something that you can try. Draw other pictures, draw other curves. Maybe I will do it here. Let's say, right? Suppose that I have some curve like this. Okay, so what happens is that you look at this right triangle, and it's very different from this right triangle, which is essentially horizontal. You see here, they are definitely not proportional. You have a long horizontal leg and a short vertical leg. Here, the proportions, they are more alike. So here the horizontal and vertical are more alike, they're of the same size. So in other curves, the triangles will not be similar. So do you understand what I'm saying, guys? Yes? So here the right triangle is almost, it has a very, very short vertical leg compared to its long horizontal leg. Whereas somewhere else in the curve, they look like they are more of the same size. So only in a line will the triangles be they will be similar to one another. So the ratio, what is similarity? It means that the proportion of vertical to horizontal in any triangle that you draw is the same. Okay, so take any 2 points from those 2 points. This is 1 point and this is another point on the curve. You can create a right triangle and you can calculate the proportion. Okay, you can calculate the proportion, and the rise divided by the run of one triangle would be the same as rise divided by the run of another triangle. They stay proportional because this line forms the hypotenuse for each of the right triangles. And that's what the slope is capturing geometrically. It also captures the idea of steepness, because you look at it for the horizontal amount of displacement, how much vertical displacement do you have, right? So if the line is closer and closer to a vertical line, you will climb this. The proportion of vertical to horizontal will be a very large number. In other words, the vertical leg is much longer than in proportion to the horizontal leg always, right? If the line is nearly flat, nearly horizontal, then you will have to move very far out horizontally to get any sort of climb. So you have, by proportion, very short rise and a very long horizontal displacement. So that's what a slope is supposed to capture. You see, so this number is always the same because the triangles are proportional. So you understand what proportion means. Proportion means, for example, if you want to scale make me very giant or tiny, you can see that my index finger is of the same length as my nose, let's say, right? So a bigger version of me will have the same property. The index finger will be of the same length as the nose, which means that index finger divided by the nose equals 1. So that's the idea, right? Every feature that you can measure, if you take the length of that feature and divide by the length of the other feature, the number stays the same if you scale the object, the figure up or down. That's what proportion means. So before I move on, is this clear, guys? And let's see then, right? So how would you see if I did not draw the line and I select a point? So let me select a point here. Let's suppose that I have this point here. This point is X, Y. This point is not on the line. You can see it visually here. Can you tell me how would you verify algebraically, let's say using this point, that it is not on the line? You understand my question, right? I have this picture here, but how would you just imagine that you don't have a picture, you're just given coordinates. You have calculated the slope of this line and you know this point on the line. How would you verify that the point I drew is not on the line? Well, obviously there's one line here, this line. How would you verify that this point I drew is not on this line? Into what equation? That's the question. So give me the equation, guys. Right, what do I do with this x and y, given that I have this point and I know the slope? Slope is m. We calculated it. It's the ratio that we have there. What would I do? That's not the most useful equation, but you can work with that. I want a full analysis. Do you understand my question, guys? If it puzzles you, then you don't know what slope is. I'm just verifying whether you understand what is an equation of a line or not. Yes, kind of, but tell me, what do I do with this X and Y that I selected? That's very good, Ibad. That's exactly my point. It will be different. So here is that other point. Let me select, let's say, green, right? So this is what I will do. I would not have any y equals mxb, but I will do simply. See, so here is my triangle that I constructed. It's obviously not similar. If it's not on the line, it's not going to be a similar triangle. So what I will do is this. I will say, I would say this. Y, that's this y, minus b1, that's this point, divided by x minus a1 okay. And then what would I verify about this equation? If the picture is like this, what would I see? In other words, this is a picture that I'm showing. Imagine that we're communicating it only in terms of algebra. You don't see any picture. You just have the slope value and you have a point on the line, but you are not actually watching this line. Can you imagine that, guys? So I'm using calculation here, right? So what should I see based on this picture? You see, based on this picture, I will find that the slope is what compared to m? This is m. M is blue divided by blue, or red divided by horizontal red. So what would I find about this ratio in terms of the slope, in terms of m? If it's 1-to-1, they are the same. Then you're claiming that this green triangle is similar to the red triangle. The new slope is bigger, correct? The new slope is bigger. So you understand, if I did not see this picture, I would interpret based on a good analogy is that you're in the submarine. You have to use this equipment, right? The equipment is giving you information that you do not directly see. Do you follow? Because when I give you the slope of a line, when I give you a formula, you are not you're not seeing the picture. You're figuring out what the picture is based on the calculation. So that would be bigger than the number m. Do you see that? Because rise over run is bigger than m. So in this case, I know that xy that I selected here is not on the line. Good? You follow what I'm saying? Not enough of you participate, so I have a feeling that you are spacing out, that you don't follow what I'm talking about. What about if now let me erase this. What happens if I select my point here? Let's say I picked my point xy here. What would I observe? And I can use this point here. What will I observe about the slope? Or actually, let me make it. I don't know. Let's keep it for now like this. I don't know how confused you are or not. What would be the situation now? It would be much less or not, but it would be a smaller slope. The line is less steep. Smaller slope, guys. Everybody understands that? Smaller slope. And how would I actually see it in calculation? Imagine not seeing the picture. Not seeing, so I haven't drawn the line. If I don't see the picture, I see this. In other words, only the inequalities will tell me what's happening. It's this and then that. So you can see that this line compared to this line is much smaller. So I will observe that y minus b1 divided by x minus a1 is less than m. Make sense? So now I know exactly how to write equations of a line. So equation of a line is that if I select a point xy, if I select this point exactly on the line, if xy is on the line, then the slope is y minus the initial point I selected divided by x minus the initial value of x has to exactly equal the slope. So the set of points on a line is the set xy that will match the slope that we have forced to have this line to have, right? So if we know the slope of the line and we know a point on the line, we can define every other point on the line to be the set of all xy that when you use them to calculate the slope, you will get the number m. You follow? That's how the equation comes around. Y equals mx plus b is just a modification of that equation. Good. So here's the equation. Y minus b, x minus a. If the point ab is given to us and we know that the line has slope m, then the set of all other points can be defined to be y minus b divided by x minus a equals to m. In other words, if I use that second point together with the initial given point and I calculate the slope, I will always get m. And that gives me an equation of the form. I can just move it around. I can multiply both sides by x minus a and it gives me the point slope form. Y minus b equals to m x minus a, which if you want to, you can simplify it. You can write it mx minus ma plus b, which is your other form of the slope. And here is now the idea from calculus. How do we calculate the slope of a tangent line? So to calculate the slope, we always need 2 points on the graph. So suppose that we want to know the slope of the tangent line at the point P. So at some point on the curve, I want to know what's the slope of a line touching P. So what I can begin doing is I can select another point Q. So this point is at A, f of A. I select another point Q. And at the point Q, I have coordinates x, f of x, you see? This point Q is at x, f of x. And the line going through those 2 points clearly goes through at least 2 points, so it's a secant line. And I can calculate the slope of that secant line. The slope of that secant line is going to be f of x minus f of a divided by x minus a. This is the slope of the secant line. Everybody with me? Let me just check. Not everybody. So are you with me, guys? It's very important. I want you to really realize why this formula works and what it is about. So that's my secant slope. I just picked one fixed point. I want to slope through P, and I pick another point Q. And I use the 2 points to calculate slope. So it's f of x minus f of a over x minus a. Now, what do I do to make it more and more like the tangent line? I want the curve trace to cut as little as possible of, so the line should cut as little as possible of this curve. So what I do is I will slide the point Q closer and closer to P. And I will do that by making x go to A. You see, if x is very close to A, move the x here, the Q will follow, and it will be close to a P. So this red Q and this P, they are already much more of a tangent line. In other words, what you do is you merge the 2 points of intersection of the line, so it now looks more like the trajectory of this line grazes the curve, does not pierce through it as much. Okay, so the slope of the tangent line is defined to be the limit as x goes to A of the secant slope. So I think of it usually as a trajectory of a bullet. So here, the bullet went through the curve and cut quite a lot of this curve, right? But if I make Q the entry and exit wound, so P is the entry wound of the bullet and Q is the exit wound, if Q is really close to P, it will be more and more like the bullet just grazed you. It did not go through. And here is your first task, okay, guys? So let's see if you understand it. Find the equation of the tangent line where the curve is x squared, and I want it at x equal to 2. So let's go ahead and calculate that.
Professor, I have a question.
Go ahead.
I was wondering, because I'm working this thing and I kind of stopped at the limit, but are we supposed to kind of come up with like the 2 points that we need?
Well, that's what we did over here. You see, that's so we 1 point is fixed. The 1 point that is fixed is at x equal to 2. Yes.
Oh, got it. Okay.
You see, Gabriel, you see, when you show both formulas, that's bad. You don't need to see the formulas. Do you understand the formulas? If you do, then you can write them. It's coming from your heart. You see, when you need to see them, you say you understood the slope of the line. No, you did not. If you need to see them, you did not understand.
Oh, okay.
Okay, so here is the idea again. Do you understand the idea, guys? You see, don't memorize a formula, understand the idea. The idea is first, do you understand what slope is? Slope can be calculated once I have 2 points, correct? So between point P and point Q. So I'm interested in some particular slope at the point P, the slope of the tangent line, okay? And so I begin by calculating the slope of a secant line. In other words, of a line that just arbitrarily crosses P and some other point, Q. So the arbitrary point Q will be at coordinates x, f of x, because it's part of the curve, right? So every point on the curve is x coordinate, f of that coordinate. That's the y value is f of the x coordinate. So this point has coordinates a, f of a. This point has coordinates x, f of x. Yes? And now the slope between those points is f of x minus f of a divided by x minus a. Yes? And then what do? You see, we don't really want this slope. What we want, the idea is this: if Q is very close to P, then the line, the secant line cuts into the curve less and less. You can see that this point is closer and closer and closer. So they merge to 1 point, it becomes like a tangent. That's the idea. Make sense? So what is a tangent? A tangent is where that's the Newton's idea. Tangent is where you have 2 points, but the 2 points are merged into 1. You see, secant, you have crossing through 2 points at least, right? But if you take the other point and merge it to the first, now the 2 points are very near each other. So it looks like 1 point now. So you're using the limit to say, well, we're getting the tangent line because we are getting the 2 points to merge into 1 point. And how do I do that? I make x go to a. You see, I can control Q by making the x coordinate go to the x coordinate of the fixed point of P. So that's why my limit is this. Okay, so now the question is, we have y equals x squared and x equal to 2. So we have this function, we have the x coordinate of the point at which we're interested to find the equation of the tangent line. And so use this information to calculate the slope of the line, and then write the equation of the line. Sure, possibly, Kirill. I want you to do it by the definition, right? And make sure that it's not a shortcut that you're using, because if you're using a shortcut, I have to wonder if you understand why the shortcut works.
Wait, I'm sorry. What did you say, Professor?
Well, it looks like you are right, but the question is, how did you obtain it, right? It's not only what you obtain, it's also how you obtain it. It has to be through reasoning, otherwise it's meaningless. You understand what I'm saying?
Yeah, I got you.
Yes, in other words, some people took calculus before. They memorized a few techniques that work, but they don't know why something works. If you use something that you don't know how it works, then it's not mathematics you're doing. That's my point. We will use all sorts of shortcuts, but we want to understand it. That's the only way that we actually can implement those ideas if it ever becomes interesting to us. Like, let's say, so you need to really understand the subject very well to be able to use it, if you ever want to use
it. Yeah, okay, understood.
So how did you do it? Using the definition or using the ideas that I asked, or some other way?
I mean, I just used the formula, but I have because I took calc last year, so I had a different variation.
That's why
I understand the concept of like the tangent line and like why we need to find it and its location relative to the equation that we're observing. Mm-hmm. And I know we're going to use it later as well, like what it's going to relate to. But I mean, my equation was a little different in terms of solving.
Your technique of solving was different.
Yeah, like when it comes to
definition, you will see afterwards why. You see, the definition is the most important thing. It's not only, guys, by the way, to just slow you down. If you understand what I'm going to teach you, all the questions will look like the same thing to you. Okay, so every limit that you see, I showed you in the previous notes, there is a question that I can give you an hour or 2 hours, and let's see if you can do it. I think it will take you a while. I can do it in a second because of recognition, because I recognize that this equation relates to something else. So that's what we will train. Okay, I want you to right away realize what the definition of the derivative looks like.
I think I might have gotten it. I did it. I got it's gonna sound weird. Like it's 4.
The slope is 4.
Yeah.
So very, very good. When you say it, make sure that you remember what it refers to. It is the slope.
Yeah, okay. The slope is 4. I got 4 at least.
That's great.
But I think the way I did it was kind of weird.
What is weird?
Because I took the example that you had previously shown us, and I just kind of like doubled the top, because y equal to x to the second power would be x2. So I multiplied 2, so I got 4.
I'm not sure. I'm not sure. So first, guys, a small hint.
Yeah, I got something like that. Wait, can you scroll down?
Down. I will scroll down.
Yeah.
I don't want to reveal my
Where the
answer.
solution
Other
is.
people worked it. All right. So
Excuse me.
x equal to 2. No, it's great. X equal to 2 is just part of the coordinate. A point has to have 2 coordinates: x coordinate and y coordinate. What do you need to calculate the slope? You need pairs of coordinates. One pair of coordinate, another pair of coordinate, right? So x equal to 2, you have this formula. I know what's the y coordinate. The y coordinate is 2 squared, correct? So I have 1 point, and the other point is x and x squared. Is that what you did?
Yeah, so I got like x squared minus 4 on top, on the numerator.
That's absolutely right. Because what is this? This is y equals x squared. We have a general relationship between a point, between the x coordinate and the y coordinate. This means that this parabola is the collection of points where the second coordinate is the square of the first coordinate, right? So if x is 2, the second coordinate on the parabola is 4. And for another point that I just need to select P and Q, right? So P is the concrete point. It's 2 and 4. And the other point Q is the sliding point. It cannot be concrete because we are going to change it all the time, right? So it's x, and the other point is x squared. So if you did that, that's excellent. So you see this, guys, right? So I need 2 points, very simply. Calculate the slope, I need 2 points. What is 1 point? It's 2 and 2 squared. What's the other point? X and x squared. And I calculate the slope between them, and then I push x to 2, because I want the 2 points to merge into the same location. Does it make sense? Idea is extremely simple. 2 points on the curve. So the curve is, I know to make the points on the curve, as soon as I have the x coordinate, or I right away know what should be the y coordinate. So I select 2 points on the curve, and then I slide one of those arbitrary points to the fixed point that I already selected.
Okay.
Yes? So let's solve it, guys, and then I'll give you another one to work with it. So very simply, you understand how I do it, right? I imagine at least this much. There is a curve, there is some graph. I don't have to visualize the graph to carry out this calculation. On this graph, exactly, how did I find the points? Very simply, I am told, look at this question, guys. You see, there is this difference. So one small difference, and you are thinking like me at least already, right? So most people, what they see is just they want to execute a procedure, but they don't think about what the procedure means. So here is what I visualize. I can, of course, visualize y equals x squared. I see how it looks like, but I don't need it. It can be any other curve. So I'm saying I have a curve, and I need to find a tangent to this curve where x is equal to 2. What do I mean by x equal to 2? I mean, that means that the point at which I'm finding, at which I'm calculating the tangent line is 2, 2 squared. Because what is this curve? When you specify a curve using a function, you are telling me how the y coordinate is determined by the x coordinate. You understand? That's what a function is. Y coordinate is determined by the x coordinate. So the full point, let me write it for you. When I say x equal to 2, that means that my full point, if it's on the curve, has to be 2 squared. Are you following me, guys? When I say y equals x squared, all I'm saying is that we have a curve where I always find this regularity. The second coordinate of a point is always the square of the first coordinate, right? So I definitely have 1 point on the curve. Now to calculate a slope, I need another point, right? You can see that I'm holding my 2 fingers. You can mentally connect them by an invisible string. So that tells you that 2 points determine a line. That's why a line is the simplest object, right? It's determined, the simplest curve is determined by 2 points. Other curves require more than 1 point to determine it. More than 2 points, right? So quadratic functions require 3 points to determine them. Cubic require 4 points to determine them. You understand? So you can actually feel how the curves become more and more complicated. We will get there as well. It's an important idea. So 2 comma 2 squared is 1 point. Now that's my point P at which I want to calculate tangent line. Yes? Now the other point that I need is an arbitrary point that I will slide. So its coordinates are x, and then the second coordinate is x squared. And that's my point Q. Yes? And now I can use those 2 points to calculate the slope. So what do I do? So slope between P and Q is simply x squared minus 2 squared divided by x minus 2. That's my slope calculated from those 2 points. Are you with me, guys? You see, I don't see your reaction, so I'm not sure if I communicated well enough for you. It's obvious, right? It makes sense? Do you understand what I just calculated? So I just carry out that general recipe that I had over there. Now, this is not the slope I'm interested in, correct? Why is it not the slope that I'm interested in? Now, let me just verify. Could anybody tell me, type in the messages or speak to me, why x squared minus 2 squared over x minus 2 is not quite finished? What's wrong with that?
If you were to plug in the 2 now, then you would have gotten 0.
Sure, that's you're already seeing a slightly one step ahead of what I asked. I'm asking, you see, so those are 2 points. That's not a tangent line, right? So you see, we just picked 1 point and another point. If a line goes through 2 points on the curve, it's not a tangent line. So then the idea, that's the last thing that you have to understand. The idea is I take this floating point, that's the x, y, this is my y, this is my x. I take the floating point and I move x towards 2. Because that will move x squared towards 2 squared. You see? And when I do that, you see me in the camera, right? When I do that, right, the 2 points, they are merging into 1 point. You understand? You had 2 points, secant, 1 point, tangent. Is it clear? So and you cannot just right away plug 2, because if you plug 2, as Alexa said, you get 0, right? So that's why you use limits. You're doing it careful. You have to somehow do both things. Keep them as 2 separate points and yet claim that it's 1 point. And limits allow you to do that rigorously. Make sense? Because there are 2 points, but it looks like 1 point. So if x squared is very close, it will look to you like it's 1 point. So it will not be exactly the tangent line, but it will be very close. And if you take the limit, the perfection is only increasing, and you can just predict what the slope looks like. Good? Okay, so hopefully that's settled. And you don't need to see my, this picture you should have in your head. You see, if you understood the idea, you don't need the formula. You just right away know it. Learn it my way, guys. It's a little harder first, but if you understand why things work, they're just all the questions that you might have, many of them, sorry, are eliminated entirely. So if you just, is this correct? Is that correct? If you verify every step, you don't understand, you are making it only harder on yourself. So then I have this limit, x going to 2. I have this ratio. I can factor out the numerator. I simplify. I cross out x minus 2 because x approaches 2. It's not equal to 2. So now I have limit as x goes to 2 of x plus 2, and I get that the limit is 4. You understand? And wonderful, Alexa, that you got it. So we have 4. What is this for? That's the slope of the tangent line. And once I have the slope of the tangent line, and I have a point, this is a point. Now, what's the equation? I'm sorry, I always say the equation, but it's an equation. There are many equations that describe the same line. I can create infinitely many equations. They will all describe the same exact line. So I should probably say an equation. So here is what you do, right? Or very simply, an equation is this. If a point, xy, now xy is on the line, and then I have to have y minus 4. That's the y coordinate of the point at which I calculate, divided by x minus 2, because 2, 4 is a point on the line, and the slope we calculated to be 4. So the answer is supposed to be 4. right? If I calculate now that I know the slope and I already have 1 point on the curve, it's now very easy to describe the equation of the line, because that's what I mean when not seeing the line. You see, like in the picture above, I gave you a line, and I asked you, how do you verify that a point is not on there? And some people are bothered by it because they say, well, it's obviously not there. In space, the point xy is not lying on the line that I drew there. But what you have to realize that you usually just have information, but do not actually directly see the line, because you haven't, you see the tangent line, you don't see it right away, right? Unless you write the equation. So you just found out that it has slope 4, and it has the point 2, 4 on it, on the curve, or on the line. So that means that any other point on the line, xy, will satisfy this property, which means y minus 4 equals to 4 times x minus 2. So you can write it in other form, but I do not need to solve. You don't need to solve more than is required of you. So you can, of course, write this equation in this other form. You can say that this is the same as y equal to 4x minus 8 plus 4, or simply y equals to 4x minus 4. Okay, this is also correct, but you did extra effort, right? This is a point slope form. That's enough. You can stop there. Once you have an equation, you can stop. You can stop there. You don't need to continue. So is this example so far clear, guys? Or can I move to the next one, or you want something else? We'll see if it's clear, right? So I wanted to hear you guys say yes. Type yes if you follow, and you can move to the next example. It worries me. You say guys, you say yes, but you realize it, like what I'm asking you to. Right? You see what I'm saying, right? What I do is I do not see the line. I'm just using my mathematical tools to like I'm inside a submarine. I'm using those things to infer what the line is like. Okay, and why is the equation capturing this idea, right? I'm just saying that the line is a collection of all points that if I use that point and the point P, and I calculate the slope, I get the slope 4. And that gives me an equation of a line. So here is your next task. Find the tangent line to the curve y equals f of x, where f of x is minus 3x squared plus x plus 5 at x equal 1. And then the second part is maybe you can figure out a general form of the equation of a tangent line at any arbitrary point a f of a. But first, let's do it at 1. So here is your curve. We have a formula for it, but we don't have a picture of it. And here is a point. And I want you to infer what is the tangent line to this curve at x equal 1. Our class ends today at what? At 1 or 1:15? I don't remember. 1:05. Okay. Yes, pretty much. But it's not always worth to finish the calculation. Sometimes it's easy to keep it in. Let's say if when you plug 1 here, it's minus 3 times 1 squared plus 1 plus 5. Sometimes those ideas are making it easier. How is it coming along? Okay. It's easier when you don't when you keep it in point slope form, because everything else you do, you're doing extra calculations.
Okay, got it.
Okay, let's see. Okay, but interesting. So we need to see just a few more things. You forgot, but I think you mean parentheses around x minus 1. So it's minus 5 parentheses x minus 1. And guys, if you figured it out for 1, I want you to try to figure it out for the general a f of a. How are you going to use that mx plus b to find the slope, ping ping? You need m. That's the most, the slope is pretty much it's 90% of the effort, find the slope.
I'm sorry, Professor, what do you mean by general equation for the point?
Well, here is a point, a f of a, what the slope would look like. If I'm see, so you try to standard.
Oh, so you mean if we didn't have an exact value?
You try to figure out the solution. You see, would you start if I gave you x equal to 2? Will you start the entire process again? If I gave you x equal to minus 7, will you start the entire process again? It seems much.
Okay, understood.
It,
yeah, I got you.
And then just plug and play. You understand? So what you do is you try to solve in the most possible general setting, so that the answer is right away apparent, that you don't have to repeat the same work again and again. You see, guys, when you don't understand something, you are doing redundant work. It's always this the case, right? So there is always a more efficient way of doing something. When you memorize, you're using way too many resources of your brain for this particular topic. Are we ready to discuss the solution? And not too many of you messaged me. I see only a few solutions here. Well, how many did it? 1, 2, 3, 4. Only 4 people gave me a solution.
I got stuck on trying to FOIL it out.
Okay. There is actually I'll show you when you do it in a general way. You will FOIL it very simply, very fast.
Okay.
So the one thing that people do, they carry out more calculations, right? I tend to do the minimal work possible. So many people, they think, okay, well, they are saving their energy, but they end up actually doing more work than they have to. So when you are simplifying it and you write y equals mx plus b, you did more work than you had to, for example. But they do that also when with algebra. So the thing that they can perform, they tend to overdo. Okay. So let's solve the first one, and then we will return to this entire thing. So here is what happened. So I did just because I would have never actually calculated to be 3. I would have not solved it this way. But let's say that most of you would plug in 1, and you see that the full point is 1, 3. That's the point at which I want to find the slope of the tangent line. So any other point is of the form x f of x. What is f of x? It's minus 3x squared plus x plus 5 minus 3. Yes. So 5 minus 3 is 2. So it's minus 3x squared plus x plus 2. And then the hint, one thing that you can right away know how to follow it is that it has to be divisible by x minus 1. You can use long division if you cannot figure it out or whatnot, but you know that one of the factors has to be x minus 1 because it has to be cancelled. Okay. So it's minus 3x minus 2. And what I do then is I just simply well, this is the factor, okay, and I cross it out. Let me show you another way of seeing that. Okay, so I would have not calculated it to be minus 3. This is what I would have done. I would have actually right away solved it generally. It's easier to solve it generally than to solve particular problems, in fact. But here is how I would factor it out. So I would have written minus 3x squared plus x plus 5. You see, and I would have not calculated it to be 3. I just plug in 1, and what's the is it at 1? It's minus 3 1 squared, correct? Plus 1 plus 5. Are you with me, guys? You see, so you carried it and you said that the answer is 3, but I personally would have not done that. I would have kept it open like this. And now I will take a like and group it with like. You see this? And you see this. They look very similar. I will group them together. This guy I will group with this guy, and this guy with that guy. So what do I get? I get, when I group it, look at it, it's minus 3x squared minus 3 1 squared. So I can factor, look at it, you see this term? So it's really minus 3, and then in parentheses I have here x squared minus 1 squared. That's what it amounts to be. It's always this minus 1 squared. So I factor at minus 3. Then I have x minus 1. So it's plus x minus 1. You with me? and the 5 minus 5 disappear. So I factor it this way. And now x squared minus 1 squared, you all know how to FOIL. So it's really minus 3, parentheses, x plus 1, x minus 1, plus x minus 1. Yes? Are you with me, guys? And then notice that x minus 1 is a common factor. So I can write this now as minus 3 times x plus 1 plus 1 yes, multiplied by x minus 1. Any questions so far? You see how I did it? I factored it by not bothering to do too much algebra. You see, you made it more complicated to yourself when you noticed that when you said that f of 1 equals to 3. All of you just carried out this calculation. I would not have carried this calculation. So I factored it out this way. I would in fact not do it with 1. I will do it right away with the abstract point. Okay, because it's actually easier to work with abstract point than to work with a concrete number. Good. So now when I divide, I'm left with, so it's minus 3 times x plus 1. If you want to, you can simplify it, but no point, right? It just so the answer is, let me erase this. So this is this minus 3x minus 2 is the same result that I just showed you over there. You cross out x minus 1, and then you push x to 1. It's minus 3 times 1 minus 2, which is minus 5. So this is minus 5, and you get y minus this point. That point ends up being 3 here, equal to minus 5 times x minus 1. The slope is the important part here. And here is doing it in general. That's the idea that I just illustrated it with 1. I would have not bothered with 1. I would have done it in general right away, because then I know all the slopes. It's like I solved infinitely many problems, infinitely many slopes with one effort. So if so the slope at the point a f of a is the limit as x goes to a of f of x minus f of a divided by x minus a. Now what happens here? This is the value at x, this is the value at a. So now I group like with like. Same thing that I did with 1, but notice I do it with a. So it's minus 3 x squared minus a squared plus x minus a over x minus a. And then I factor out this. This is minus 3 x plus a x minus a plus x minus a. And here I factor out x minus a. So it's minus 3 x plus a plus 1. I cross this out. And now I can push the limit as x goes to a. And that becomes minus 3 times 2a plus 1, or minus 6a plus 1. Notice if I plug 1, it will be minus 6 plus 1, which is minus 5. Yes? And my general equation is, in terms of a, it's y minus the value of the function at a equal to the slope at a times x minus a. So this is the equation of every tangent line possible at the same time. Just if you now want the tangent line at 0, plug a equals 0. If you want the tangent line at 5, plug a equal to 5. You understand the difference between what I do and what many of you are doing, right? Is that I'm more efficient. I'm not smarter, but more efficient. And why am I more efficient? Because I figure out a general solution. It's not many problems, it's one thing. Okay, now here is another example, guys. Let's see if you could find the slope of the tangent line at x equal to 9. And let's see if you could do it in general. That's pretty nice. If you see, try doing it either at 9 or try doing it in general. Let's see if you can accomplish that.
Professor, I'm am I stuck? I don't know. So, good question. So, what are we supposed to do after you kind of break up the square root of 3? I mean, the square root of x minus the square root of 9. Like, you're supposed to break it up, but like, what are you supposed to do to the denominator?
Well, that's a great question, right? Either numerator or denominator, you can modify the problem so that you can cancel something out. Obviously, you want to get rid of x minus 9 on the bottom.
So we're trying to get rid of x minus 9. Okay.
Right. So you see, because the denominator is what makes us not be able to plug 9, right? So it's really something divided by x minus 9. And if and I want to be able to plug 9 into the formula, then I will know the slope.
Okay.
Right, guys, I'll be back in 2 minutes, and you go ahead and think about it. And if you finished it, guys, can you find a general formula for the slope at any point on this graph? So y equals root of x. What's the general formula for the slope? Can you figure it out? So the same thing, but not necessarily at x equal to 9. Can you just figure out what is the, see, so let's say I asked you to solve the, to figure out the equation of the tangent line at x equal to a different value. How would, you don't want to repeat the same problem again and again. Can you find a general slope formula at any point? There should not be an x if in the slope formula. But yes, maybe you're very close to the right answer, Khalil. Let's see how many of them. 1, 2, 3, 4, 5, 6. Only 6 people solved it, guys. I have more than 6 students. I have 30 here. What about the rest of you? Not exactly, Khalil. Some mistake in here. You understand about the what is the point of the general equation, guys, right? So you see, imagine I ask you to solve it for x equal 9, x equal to 10, x equal to 100, to 1/2. You see, I can give you so many numbers and it gets annoying, right? Can you carry out a procedure that solves all those problems at the same time? We'll do it in a moment, guys. Just I want to give you a shot to figure it out. Okay, good, Christian, good. All right, let's walk through the solution, guys. So very simply, this is the formula with concrete 9, right? Root of x minus root of 9. So one thing that you tend to love doing is whenever you have a root minus root, you multiply by root plus root. You agree? It's just you can multiply by the conjugate. There is an equivalent way of doing that, but you love multiplying by the conjugate. You don't change the equation because you multiplied by 1, correct? And so when you do that, numerator becomes x minus 9. X is positive. If x goes to 9, x is positive. So root of x times root of x is just simply x. Minus 3 times 3 is minus 9. So we have this expression, then we can cancel it out. We are left with 1 over root of x plus 3. And when I push x towards 9, it's root of 9 plus 3, or 3 plus 3 on the denominator, which is 1 over 6, which means my equation is y minus root of 9 equals to 1 over 6 x minus 9. Do you get it? How many of you, I mean, I only received what, 5 or a few solutions. How many of you got that? Great. Now, let's say I wanted to solve it at another number. Okay, great. Let's say I wanted to solve it at another number. Let's try this, see if this device works. Okay. So the general situation would have been something like we have the point so we have the point it logs. I don't know why. I guess I have to use it. Use another thing here. 1 second. So suppose I had a root of a, and that's 1 point, and I want to calculate my slope over there. Can you hear me, guys? Okay, great. Okay, so this is so a root of a, and what do I do then? So then my other point would have been x root x, yes? And with that other point, I can calculate slope. So I have root of x minus root a divided by x minus a. Good. And so what can I, and I take limit as x goes to a. So what do I get when I take this limit? Well, limit where x goes to a, I can multiply top and bottom by the conjugate. Or in fact, I can factor the denominator. What is the denominator? That's another thing I like doing. I tend to like it more, factor the denominator. This is the same thing as root of x squared minus root of a squared, correct guys? And here we have root of x minus root of a. Good? You are seeing my screen, correct guys? Great. Okay, so we have this expression. I can now factor the denominator. I could have multiplied by the conjugate, or as you see, factor the denominator. So what do I get? I get that this is simply limit where x goes to a, and the denominator can be written as root x minus root a multiplied by root x plus root a, and the numerator is root x minus root a. I can simply now, I can then cancel it out. I can cancel this and that out. And now what's the limit? The limit is simply 1 over root a plus root a, so that would be 2 root a. In other words, I now know how to find the slope for any a. If a is 1, the slope is 2. If a is 2, the slope is 2 root 2. If a is 16, that will be 2 times 4. Good? I found the slope. So now what's the equation? The equation simply now is y minus root a, because that's the y coordinate of the root, equal to 1 divided by 2 root a x minus a. So I figured out an equation of a line that works for all of them. So Joshua, what do you mean by, so it's 1 of over root of x plus root of a. You follow me, guys? Make sense? That's how simple it is. You see, I solved the problem for all possible combinations here, right? Not just for 9, but and I could have multiplied by the conjugate, but I decided to actually factor the denominator, which I can do because x is root x squared, a is root a squared. I can write the denominator as the difference of squares and factor it out. I can do also multiply by the conjugate, but I prefer this method. especially once you have cube roots. I'm going to introduce in the next lecture some other ideas. Okay, so we're going to figure out how to do that for all sorts of functions. And let me remind you guys why this is important. What sort of idea does it do to us? Does it give us? One more moment, and yeah, so remember the last lecture. By the way, did I finish with infinity with you? Have I finished with infinity, or maybe I did it with the other class? I haven't finished infinity, have I? Yes, you see the other class. So next class, I should also finish with the infinity part here. I forgot that you haven't seen everything. So this is the question I had. Did you see this question? Maybe not. So how long will it take you to solve this question? I can solve it in 2 seconds. All right, guys. So today's class is over. You can think of this question, write it down, and see how long it will take you to solve this, just as a curiosity. I'm not revealing my solution. I just tell you what the answer is. All right, guys. So today's class is over. We will go and finish the infinity part next lecture. I forgot that we haven't done it with you. If you have anything that you want to talk about, you are welcome to stay a little bit. Otherwise, have a good weekend.
All right. Thank you, Professor.
Have a good one. All right, only a few people remain here. So any questions? I assume not. All right, goodbye, guys.